This is the second half of the guided practice problems for section 7.1. This is number 5 and 6, and these get a bit tricky. So here we go. In this case, when I'm choosing my u and my dv for integration by parts, because if you were to try to u sub for what's underneath the square root, you've got too many x's. If I were to u sub for the 4 plus 2 x squared, my derivative is 2x. So in order to take the antiderivative of that piece, I needed x. So I'm going to separate this into integral from 0 to 1 of x squared times x over square root of 4 plus x squared dx. And the reason is because this, I can use a u sub to find the antiderivative of. Okay, so in that case, I'm going to make the x squared my u. Du then is 2x dx. Then my dv is x over square root of 4 plus x squared dx. Now, in order to get v, I need to do some work. I need to use a u sub. So I'm going to go here, kind of as a side note, and I'm going to so to find the integral of x over square root of 4 plus x squared dx, I'm going to let my u equal what's underneath the square root, so the 4 plus x squared. In that case, du is 2x dx, and x dx is 1/2 du. That means we're working with the integral of 1/2 du and 1 over u to the 1/2, right? 1 over square root of u. That's going to become 1/2 times 2 u to the 1/2. The u 1/2 and the 2 cancel, and we get the square root of u, which is the square root of 4 plus x squared. So that's what goes up here under my question mark. So this is the square root of 4 plus x squared. If you're not sure, you can check it, take your derivative, and go the other direction. But it works, trust me. All right, so now we want our integration by parts. So I'm taking x squared times the square root. So that's x squared times the square root of 4 plus x squared. Minus the integral of, and we're integrating from 0 to 1. So I've got to evaluate from 0 to 1 and integrate from 0 to 1. And I'm taking 2x times the square root of 4 plus x squared dx. And again, I'm going to use the same kind of u sub here for this one. So let me change colors once again. So for this one, we're going to let the u be the 4 plus x squared, which is what's underneath the square root. And again, du is 2x dx. And I actually have the 2x dx this time. So that's what I'm going to go with. So that means I'm going x squared, square root of 4 plus x squared, evaluated from 0 to 1, minus, this becomes the integral of the 2x dx is my du, and what's underneath the square root is my u, so this is u to the 1/2. So if we take our antiderivative there, that becomes u to the 3/2 times 2/3. I can't evaluate yet because I'm not back to x's. So now I take my 4 plus x squared and plug it back into the 3/2. Now I'm going to be evaluating this, so 3/2 is really the square root to the 3rd power. So actually, let's leave it that way. I don't think we're going to get anything better than that. From 0 to 1. Okay, so don't forget to bring back your boundaries. And let's see, when we plug in 1, we get 1 times the square root of 5. When you plug in 0, you get 0 because the x squared is 0. Minus. When you plug in 1 here, you get 2/3 times this 5 to the 3/2. And when you plug in 0, so minus a negative 2/3, when you plug in 0, you get the square root of 4 is 2. 2 cubed is 8. So this is the square root of 5 minus 2/3 5 to the 3/2 plus 16 over 3, which is a pretty ugly answer. but that is what we get. And then lastly, number 6. Okay, here's a similar one where we have an exponent that's negative t squared. So if we want to u sub for that, the derivative of negative t squared is negative 2t. So I need to keep a t with that. So I'm going to split this to be the integral of t squared times t e to the minus t squared dt. So I'm going to separate these two things. And I'm going to let my u be the t squared like we normally would, which means that du is 2t dt. Then your dv is the t e to the minus t squared dt. And we're looking for v. Okay, let's go over here to the side to get our v. So we're trying to find the antiderivative for t e to the negative t squared dt. I'm going to let u be negative t squared. Then du is negative 2t dt. I have the t dt, but not the negative 2, so let's divide that over. So this is negative 1/2 the integral of e to the u du, which is just negative 1/2 e to the u. And when we plug that back in, we get that the antiderivative, or the integral of t e to the negative t squared, is negative 1/2 e to the negative t squared. Okay, that we can bring over and use in our integration by parts. So this is u times v, so negative 1/2 t squared e to the negative t squared, minus the integral of these two multiplied together. So the negative makes this positive. 1/2 times 2 goes away, and we have t e to the negative t squared dt. Here, I don't have to use another by parts because the derivative of t squared is the t, which is right there. So I'm going to use a second u sub. So I'm going to get u equal negative t squared. Du is negative 2t dt. So this becomes negative 1/2 t squared e to the minus t squared plus the integral of, oh, I forgot, we only have a t dt here, so let's divide by negative 1/2 both sides. So this becomes negative 1/2 times e to the u du, which is, let's see, negative 1/2 t squared e to the minus t squared minus 1/2 e to the u plus a constant, and then I just have to sub back for my negative t squared. So minus 1/2 e to the minus t squared plus a constant. And that gives our final answer.